surface area. First problem, we are told that f of xy is 2x plus 2 pi, and the area is the triangular region with the following vertices. So basically, we are talking about this region here. Here is 0, 0, 0, y, z, x, and 2, 0, 0, that's 2 under x, and 0, 2, 0 is 2 under y, and there it is. That's in their xy plane, so let's draw it that way. 2 to 2. This is the equation. X plus y is always 2. That is, x is y minus 2. In case we need it, y is x minus 2. Y equals x minus 2. Something I don't like. X equals 2 minus y, and y equals 2 minus x. Okay. Now, we want to find the surface area. And the formula for the surface area is the double integral of the square root of 1 plus partial of x with partial of f with respect to x plus the partial of f with respect to y squared dx dy. Okay. Well, what is fx? What is fy? Fx, the partial of this with respect to x is 2 plus the partial of that with respect to x is 0. 2 plus 0 is 0. Symmetrical between x and y. That is, fy, just we'll copy that and interchange x and y. That is, it's just 2 as well. So you get the double integral of the square root of 1 plus 2 squared plus 2 squared. That's the square root of 9. This is just 3. It's just 3. Okay, to save a little space, I worked it out for you. 1 squared is 1, plus 2 squared is 4, plus another 2 squared is 4. That's the square root of 9, which is 3. Dx, dy. In fact, you can put the 3 in front. Now, coincidentally, I wrote dx, dy. X comes before y. I generally write x before y. Now, I would like to have this a little bit bigger because this is very important. X plus y is 2. X plus y is 2. Bringing the y to the other side. Bringing the x to the other side. So, I want to know what x goes from. Well, right here, x is 0. And right here, boy, was I right on the money. Just where I put it. X is 2 minus y. And y goes from, remember this was 2, y goes from the least, which is 0, to the highest, which is 2. And there it is. That's the integral set up, and now we need to go and we have 3 students and do the integration. So it's the integral of 3 times the integral from 0 to 2, 0 to 2 minus y, dx, dy. Well, the integral of dx is x. The integral of dx is x, from 0 to 2 minus y, which is just 2 minus y. So it's 3 times the integral from 0 to 2 of what's in the big brackets, namely 2 minus y, dy. 3. The integral of 2 minus y dy is 2y minus y squared over 2, from 0 to 2. When you plug in 2, you get 2 times 2 is 4, minus 2 squared is 4, divided by 2 is 2. When you plug in 0, you get 0. 3 times 2 is 6. That's the surface area. It's 6 units. Think about, is it 6 units? Is it 6 squared units? Is it 6 cubed units? If you have a three-dimensional object, you want to paint it. Are you going to buy linear amount of paint? Are you going to buy 3 inches of paint? Are you going to, well, let's be more realistic. Are you going to buy 100 feet of paint? Are you going to buy enough paint to cover 100 square units? Or are you going to get enough paint to paint the 100 cubic inches? Or feet, I think I said. Suppose you were told that f of xy is 2 plus 2/3 x to the 3/2. And you're given the surface, given the region, the set of all x, y's, such that x is in between 0 and 1, and y is in between 0 and 1 take away x. Find the surface area. Well, x is between 0 and 1, okay? And that's what they tell me. I'm not going to disagree. And y is in between 0 and 1 minus x. Well, y equals 0 is this. And y equals 1 minus x is this. 1, 1. Because this says x plus y is 1. This is 1, 0, so of course x plus y is 1. And this is 0, 1, so x plus y is 1. Find 2 points, you have it. Actually, this goes on forever and ever. But x is in between 0 and 1. That's the area that's trapped. That's the area bounded. So let us draw this again. X plus y is 1. That means x is 1 minus y if I need it. Y is 1 minus x if I need it. 1, 1. Y and x. Okay, so now we need to find the partials, and then we'll find the limits of the integrals. Well, first we'll find that square root mess. After we find the partials, then we'll find the limits. Fx is, well, the partial of this with respect to x is 0, plus the partial of this. Well, that's a function of x. You bring down the power, 2/3 times 3/2 is 1, times x to the 1 less is a half. And if you happen to square that, you get x. And fy is just 0. So fy squared is also 0. So what you're going to get is 1 plus fx squared plus fy squared is 1 plus x. Get the square root of 1 plus x. Okay. So it's going to be the double integral of the square root of 1 plus x dx dy. Now, you should ask yourself, should I convert this to polar? And, 1 plus x, that doesn't look friendly. This doesn't, that's not an equation of a circle or a part of a circle. I wouldn't convert this to polar if you paid me to do so. Now we need to figure out what the limits are. I wrote dx first. dx. Well, x goes that way. I know that x is always 0 anywhere along this line. So right here x is 0, and right here x is 1 minus y. 0, 1 minus y. Inside this triangular region, the least y is 0. The most it is good old 1. 0 to 1. Now, what is the integral of the square root of 1 plus x dx? And this is the integral of 1 plus x to the half dx. If I call this u, then that's du. Okay, so I get u to the 1 more, which is 3 halves, divided by 3 over 2. And this gets evaluated from 0 to 1 minus y. Now remember, these are x limits, x. The 2/3 I can factor out. First you plug in that 1 plus 1 minus y is 2 minus y to the 3 halves minus. You plug in 0. 1 plus 0 is 1 to the 3 halves is 1. Okay, so that's what you get. All right. From 0 to 1 we integrate now. The integral from 0 to 1 of the 2/3 I pull in front, 2 minus y to the 3 halves minus 1 dy. 2/3. If that's u, the differential is not dy, it's negative dy. So I'm going to have a negative. And basically, you add 1 to this power, you get 5 halves, and then you divide by 5 over 2. Minus the integral of 1 dy is y. And this goes from 0 to 1. The 2/3 I factor out. When I plug 1 in here, 2 minus 1 is 1. 1 to any power is 1. So you just get the negative 2/5. You get negative 2/5 minus y is 1. Minus, now you plug in 0. 2 minus 0 is 2. So you get the negative 2 in front. You get 2 to the 5 over 2 over 5. There's that negative. I can combine those 2's. Add the powers. Get 7 over 2 over 5. Negative 2 to the 7 over 2 over 5 minus, when you plug in 0, you get 0. So minus 0. Okay. So what you get is 2/3 times. Since you're taking away a negative, that's going to become positive. And it's the only positive stuff. Is 2 to the 7 halves over 5 minus 2 over 5 minus 1, which I'll think of as 5 over 5. So you get 2/3, everything's over 5, 2 to the 7 over 2 minus 7 over 5. That is 2 times 2 to the 7 halves minus 7 over 3 times 5, or 15. Okay. It's a very straightforward problem. And you get a little break here. You have to remember how to integrate polynomials and how to find partials, but it's fairly mechanical. Suppose you were told that f of x, y is ln of x. let's make it a little different. Ln of secant x. Well then, fx will be ln of anything, put the anything in the bottom, put the derivative on top. It's just tan x. And since it's not a function of y, it will be 0. So the square root of 1 plus the partial of x squared will be plus tangent squared x plus the partial of y squared. Well, what's underneath this square root sign is secant squared x. It's an identity that you're supposed to know. And the square root, we'll call it secant x. It's really the absolute value. You have to be careful. So, what we know at this point is the following. It's going to be the double integral of the absolute value of secant x, dx dy. And now I'm going to give you the region. The region is x is in between 0 and pi over 4. And y is in between 0 and tangent x. Now, secant is the reciprocal of cosine. And it's secant of x. So I'm going to look at the x region. The cosine function looks like this. Here's pi over 2. Right there is pi over 4. This portion goes from x equals 0 to x equals pi over 4. It's always positive. Cosine is always positive between this x. Its reciprocal will always be positive. That is why you can ignore or remove the absolute value bars. So you got to be sure about that. Okay? Now, the biggest problem I have here is that x is just 0 to say pi over 4. They told me that. Now y goes between 0 and tan x. But the last integral symbol has to, the leftmost one, has to have just numbers. So you know what? This is a case where maybe I'll do dy dx. And it works out very friendly because y goes between 0 and tangent x. And you can put x's so long as x comes after the dy. And x goes between 0 pi over 4. Now, the integral of secant x is secant x tangent x. That is, this integral right here is actually it's a constant now. So this is the integral from 0 to pi over 4. The constant of this is a function of x, and that's y. It's 0 to pi over 4 secant x. I'm bringing the constant in front. Integral from 0 to tan x of dy dx. Well, this integral of dy is y. From 0 to tan x is just tangent x. So this becomes the integral from 0 to pi over 4 times secant x times this, which is tangent x dx. But this integral is just secant x. Remember, the derivative of secant x is secant x tan x. So this is just secant x from 0 to pi over 4. Since I hate secants, I'll call it 1 over cosine x from 0 to pi over 4. Cosine of pi over 4 is the square root of 2. Excuse me. I wanted not to say that, but I did. Anyways, the cosine of pi over 4 is 1 over the square root of 2 minus 1 over the cosine is 0. So this is just square root of 2 minus, and this is 1, and there's your answer. Okay, so sometimes you really should do, must do dy dx and not dx dy. Sometimes, as I illustrated in a much earlier problem, in another section, if you do dx dy, you may have to end up with a sum of integrals, a double integral. But if you do dy dx, it wasn't. Okay, that completes this section.